Hello everyone, this is م.هۆگر, a chemistry teacher at Zhyar High School. As I promised, I'll be with you for the day before the chemistry exam to answer your questions directly, and I'm going to solve some important questions for each chapters. So, because I think I don't have enough time to review the book completely, that's why I prefer to solve only the important questions for each chapter. Please make sure to be relaxed and listen carefully. You will see many of the following questions tomorrow, inshallah, okay? Yalla, let's start. I will start from chapter 1, as always. Chapter 1, as you know, the title is Ions in their Aqueous Solutions, okay? So chapter 1 consists of two sections. Section 1, related to some general information about the ionic and the molecular compounds. Look, first of all, you have to know what are the ionic compounds and what are the molecular compounds and how they behave when they're being dissolved in water. Okay? Yalla, let's see. Ionic compounds, as you know that, they are salts and strong bases. Okay, let's activate the board. Good. Yalla. Ionic compounds. So there are two classes of the ionic compounds. You know, one of them, which is salt, okay? And another one, strong bases. Okay? So when they dissolve it in water, how they behave? They become dissociated. So the reaction of the ionic compound inside of the water is called dissociation. So you have to know, ionic compounds, they dissociate. Okay? This is very important. And molecular compounds. Molecular compounds. Look, when I say molecular compounds, I mean the electrolytes. Because forget about the non-electrolytes and non-polars. Okay? Molecular compounds, they ionize. They ionize inside of the water. What are the molecular compounds that they ionize in water? You have to know, okay? Such as acids. Acids and weak bases. Okay? They ionize. And I'll tell you what is dissociation and what is ionization. You will see them, be sure. Mainly dissociation. I have seen dissociation in Wizari exam more than 30 times. 30 times. Can you imagine? Be sure that you will see same thing tomorrow, inshallah. Okay? Yalla. But first, here we have some general questions about them. Let's solve them. Okay, question 1. Which of the following dissolves in water? Look, which of the following dissolves in water and its aqueous solution conducts electricity? What mean by conducts electricity? Okay, it means it's electrolyte. Okay? Or I think I have to change this form of question, okay? Because, you know, later after I explain something more, then I'll get back to this question. Okay? Yalla. Which of the following dissolves in water and its aqueous solution conducts electricity? Same form, okay? Conducts electricity, it means electrolytes. Electrolytes, okay? Yalla. What are the electrolytes? Mr. Electrolytes, some of them are ionic and some of them are molecular. Okay? But you know, the question didn't mention it. Ionic or the molecular one. So it talks about electrolytes generally. Look, weak acid, this is HF. HF, it's a weak acid. So weak acid is electrolyte. True, it's correct. NaCl, it's salt. It's electrolyte also. So the correct answer is A and C. Okay, good? Which of the following dissolve in water and its aqueous solution conducts electricity? A and C. But if I change this question into which of the following, it's a molecular compound and dissolves in water, its aqueous solution conducts electricity. This time only A will be correct. Okay? And again, if I change molecular into ionic, C will be correct. But generally, both are correct. Okay? Yalla. Next question. The dissociation reaction. Dissociation reaction, it's very important. Okay. We have many steps to solve the question related to the dissociation reaction. First of all, how to recognize the dissociation reaction. Look. When you see mole of iron immediately you have to know that this is dissociation reaction. Okay? Yalla. Let's read the question. For 0.75 liters solution of 2 molar ammonium sulfide, NH4 by 2S, calculate number of mole of ions. Look, you don't have to read the question completely as a first step. First, we just need chemical formula for the compound, which is NH4 by 2S, okay? Yalla. NH4 by 2S. So the first step, write the dissociation reaction for 1 mole of the compound, okay? Look, don't forget. Write the dissociation reaction for how many moles? 1 mole, okay? Yalla. Let's write the dissociation reaction for 1 mole of the compound. Water must be written above the arrow, okay? When it dissociates, it will release its ions, which are ammonium ion plus sulfide ion, okay? And then balance, okay? Here we have 2 ammonium ions, so multiplied by 2. Simply, this is dissociation reaction for 1 mole of the compound. But if you like to write all the information, this must be solid. Here they are aqueous, aqueous, because ions are aqueous in everywhere. Okay? Yalla. 1 mole of the compound, when 1 mole of this compound dissociates, it will produce 2 moles of ammonium ions, 2 moles. And 1 mole of sulfide, okay? 1 mole. So total mole of ion will be 2 plus 1, 3 moles. Okay? So dissolving 1 mole of this compound results 3 moles of ion. Okay? Yalla. Then, first step, write the dissociation reaction for 1 mole of the compound. Then read the question completely. There must be a number. There must be what? A number, and this number must be in mole always. If not, there must be enough information to get number of mole. Look, here we have 0.75 liter and 2 molar. Mister, there's no any number in mole, but you know we have enough information to get number of mole, which are molarity and liter. So let's find out number of mole. Molarity equals to mole per liter. So mole is equal to the product between molarity and liter. Okay, so it will be 0.75 times 2 will be 1.5. 1.5 mole. Look, anytime when you change some information into number of mole, this number of mole will be for the compound. We have to place this number in below of the compound, okay? So what if we have 1.5 mole of this compound, then calculate mole of ions, okay? Mole of ions, but mister, which ion? Ammonium or sulfide? Look, none of them mentioned. That means total, okay? So we're looking for the total. Now cross product, it's very easy, okay? 3 times 1.5 equals to x. So x will be 3 times 1.5 will be 4.5. 4.5, if I'm not mistaken. 4.5 mole of ion produced by the dissolution of 1.5 mole of this compound. Another question, okay? Please make sure to understand this. This is very important, okay? I haven't seen this idea in Zhyar, so you may see it, okay? Please be careful to understand this. Yalla. Again, if 80 grams of sodium hydroxide is dissolved in water in 1,000 liters of water, calculate the total number of mole of ions present in the solution. First, as I told you, write the dissolution reaction. The compound is NaOH, so it's NaOH. Write the dissolution reaction. Water is here, okay, to form Na plus OH negative. And then write the informations. 1 mole, write the information, 1 mole of NaOH, 1 mole of sodium, and 1 mole of hydroxide. Total will be 1 plus 1, 2 moles. Again, read the question completely. There must be a number. If not, there must be enough information to get number of mole. But here we have grams, okay? How to convert grams into mole? Grams into mole. Simply, okay, mole is equal to mass per molar mass. Okay? Yalla. Here we have mass, which is 80 grams, divided by its molar mass, which is 40. So it will be 2 moles. As I told you, when we calculate number of mole, it will be for the compound always. Okay? Don't confuse. So what if 2 moles of this compound dissociate in water? So calculate total number of mole of the ions. Here will be X. Okay? 2 times 2x will be 4. 4 moles of the ions. Okay. This is very important. This compound, you know, it's different from the others. How? Look. As you know, when we dissociate any compound in water, okay, they break down into 2 species, into 2 parts, positive part and negative part. But this is different, okay? We will get 3 parts, 3 subparticles of this compound when it dissolves in water. Look, KPbOH by 3, okay? How to write its dissociation reaction or how to write its dissociation reaction, no matter, okay? Yalla. H2O, K plus Pb plus 2, and 3 hydroxide ions. Okay? So 1 mole of this compound results 1 mole of potassium ion and 1 mole of lead ion and 3 moles of hydroxide ions. Total will be 5 moles. Okay? So now using this equation, you can solve this question. It's very easy. Okay? Yalla. Another topic in chapter 1, which is very important, a very common guest for Zhyar, a precipitation reaction. Okay? Precipitation reaction is very important. There are too many rules, mainly how to recognize a compound that's water soluble or insoluble. Okay? You have to know these rules. But you know, I'm just going to solve some important questions. Yalla. Precipitation reaction, this question related to the precipitation reaction. Which of the following is correct? Which of the following is correct when solutions of potassium sulfate and barium nitrate are combined? Okay? Just read the choices and you will know that the question is about something which is called precipitation reaction. First, write the double displacement. You know, okay, the steps. Write the double displacement. What is potassium sulfate? Well, I must say I don't know what's potassium sulfate. So you're going to face a big problem. It's impossible. Okay? In the next day, there will be chemistry exam and still you don't know how to write chemical formula for potassium sulfate. This is kind of disaster. I'm sorry, my dear. Okay? Yalla. Potassium sulfate, K2SO4. This is potassium sulfate. Barium nitrate is BaNO3 by 2. Write the double displacement between them. K2SO4 plus BaNO3 by 2. Okay, yalla. What are the products? You have to know, okay? KNO3 plus BaSO4 or BaSO4, okay? Yalla. Then balance the reaction. As always, when you write any reaction, it has 2 rights. The first one, it must be balanced. The second one, their physical states. About the products, okay, this is not rule to have one solid, one aqueous. It's possible to have solid by solid, aqueous by aqueous, or, okay, one solid, one aqueous. This is aqueous because it contains potassium or nitrate and SO4, yalla. All sulfates are water soluble except of those that they came with sirkei, hadi, bapir, or sirkei م.هۆگر bapir. م.هۆگر, I think it fits more, my name, okay? However, you know I'm not working with the sirka, but sirkei م.هۆگر bapir, it's better. Yalla, it's S. Yalla. From now on, Let's read the choices. The spectator ions are K and NO3. You know, the aqueous solid will be spectators. So the spectators are K plus and NO3 negative. Look, the spectator ions are NO3 and K. It's correct, but wait, okay, still there are more answers. Yalla. The precipitate is BaSO4. Yep, it's correct also. The net ionic equation is, yalla, how to write net ionic equation? This will be net ionic equation. For the net ionic equation, we will need a solid compound and the ions from the reactant Ba plus SO4 negative 2. They are aqueous, they are aqueous. Yeah, mister, this is correct also. So the right answer, all of them. Done? Good. Again, yalla, it's so special. This question for me, it's very special, please. Yalla. When solutions of BaCl2 and Ag2SO4 are combined, which of the following will be the precipitate? Which of the following will be the precipitate? First, you know, mister, the question related to the precipitation reaction. So write the double displacement reaction, BaCl2 plus Ag2SO4. Yalla. دەبێتە طريقي تنبلان نزيك ونزيك دور ودور شتيوانك يا ئاگادار تو بولي دوازدەیەوە نیە طريقي عیبە دەڵێن positive one of this side will combine with the negative one of this side, okay? So it will be AgCl plus BaSO4. And then balance the reaction as I said. So multiplied by 2 AgCl. So the whole reaction become balanced. And then this side, as I said, without thinking they must be aqueous. Here, look, mister, AgCl, Cl. All chlorides are water soluble except of those that they came with silver, mercury, and lead. Ah, this is solid. Good. PbSO4, again, it's solid. So both are solid. Is that possible? Yeah, of course. Both are solid, so both are precipitate. The correct answer, A is correct. B is correct, so B and A and B together become the correct answer. So BaSO4 and AgCl are the precipitates. And then another topic in chapter 1, which is ionization. Please, my dear, listen carefully. Here I'm going to explain something kind of challenging. So be careful, because really, I have seen many times this thing in Zhyar. I have seen it many times. So be careful. Yalla. Ionization. First of all, ionization is related to the molecular compounds. Molecular compounds. Right? What are the molecular compounds that are ionized? Acids and weak base. Or weak base. No problem. Yalla. You know, first, strong electrolytes and weak electrolytes. How to know or why some electrolyte is weak while some of them are strong? First of all, the terms of strong and weak related to the degree of ionization and dissociation. Look, let me give you some examples. Example, NH3. What is NH3? Mr. NH3, it's a weak base. Okay. Why it's weak? Because it ionizes partially. Okay? Weak electrolytes, they dissociate and they ionize partially. But strong electrolytes, they ionize and they dissociate completely. Look, again. Weak electrolytes, they dissociate and they ionize partially. But the strong electrolytes, they ionize and they dissociate completely. Okay? Yalla. And now what is HX? Look, I'm sorry HX, but these are so green. Yalla. What's HX? لەگەڵم. First, X, it stands for the halogens. Halogens. Yalla. HX. X could be chlorine, fluorine, bromine, and iodine. Okay? So HCl, HBr, HI, and HF. Look, after, you know, کاتێک ئەوم تەواو کرد سکرینی بکە ئەوە گرینگە ئیشت پێ دەوی. Okay? Yalla. So these are H-axes. They could be in their gas form and they could be in their aqueous form. Okay? So what will happen when they are gas? When they are gas, we call them hydrogen halide. Hydrogen halide. Example, HCl gas. It's hydrogen chloride. Hydrogen chloride. Okay? Yalla. HBr. It's hydrogen bromide. Okay? Hydrogen halide. Hydrogen bromide. Till the end. But look, they are gas, so they don't conduct electricity. They do not, okay, conduct electric current. But all of them are electrolytes. They are electrolytes, but why they do not conduct electricity? Because they are gas and they are molecule. Okay? Yeah. But what if they are, but what about their aqueous solution? Okay, they become aqueous solution of the acid. So their name will be like this. Look, hydro plus name plus IC plus acid. Look, HCl aqueous. It will be hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrofluoric acids. Okay? And they conduct or they do not conduct electric current. Yeah, mister, they conduct electric current because they are aqueous. Okay? They dissolve it in water. But a very important thing, all of them are water soluble. They have similar solubility. Water soluble. But these three acids, they are strong. But this one, it's weak. Mister, why they are strong? Why this one is weak? Because they ionize completely, but this one ionize partially. Okay? So, you know, these informations are very important. Section 2 about colligative properties. Yeah, the colligative property, as you know that there are 4 colligative properties: vapor pressure lowering, freezing point depression, boiling point elevation, and osmotic pressure. Okay, the first and the last one, we only study some theoretical thing about them, and the second and the third point, we have some problem, mathematical problem to solve. Okay. They direct with the concentration. It means if we increase concentration, all of them are increased in the form that we written them. Okay? Yalla, agatan lerabi. Here we have a question. This is very important question. So please make sure to understand this. It's very important. Let me take a sip of water. I'm sorry. Yalla. If freezing point of aqueous solution NaCl is negative 0.8 Celsius degree, calculate the boiling point of the aqueous solution K3PO4 at the same concentration. Look, first of all, this is really challenging question because we have both terms of freezing point and boiling point. Okay? So what we have to do for those questions when they contain both freezing point and boiling point at the same time, look, we have 2 things to do. The first thing, look, change the given information into molality, then change molar concentration into the unknown. So we have to start from the given information, which is NaCl. But Mr. NaCl, it's electrolyte. So write its dissociation reaction. NaCl, after being dissolved in water, it will produce Na plus Cl negative. Okay? So 2 moles. And then there's a freezing point of the solution. So we have to calculate molality as a first step. Molality. Yalla. Write both equation formulas for the freezing point. Delta TF is equal to, okay, you know, delta TF is equal to freezing point of solution minus freezing point of pure solvent. Solvent, okay, solvent. Yeah. Delta TF equals to freezing point of solution is negative 0.8 minus 0. Because solvent it's water, so it's 0. That's why we will say delta TF is equal to negative 0.8 Celsius degree. Then delta TF, another formula, which is equal to Kf times molality times mole of ion. Okay? Yalla. We have delta TF, which is negative 0.8 Celsius degree equals to Kf is negative 1.86 times molality times how many mole of ions do we have? 2. So mole is equal to, molality is equal to, it must be positive always, okay? It's impossible to have molality by negative arithmetic sign, okay? It's impossible. It must be positive always. So molality, I think it's equal to 0.215 mole per kilogram, okay? If it's not, you can make your own calculator, but I'm sure that it's correct, okay? Yeah, and then let's change molality into the unknown. What is the unknown? Boiling point. So write the formulas of the boiling point. Delta TB. This time it will be delta TB equals to Kb times molality times mole of ions. But mister, we will use same mole of this compound, all different. Look, here we just changed the compound into another one. So we will need a new dissociation reaction, which is K3PO4. K3PO4, after being dissolved in water, it will release 3 potassium ions with 1 phosphate anion. So together they become 4 ions, okay? How many ions? 4 ions. So delta TB is equal to, because they have same concentration, so we will use this concentration in here, okay? Kb is 0.51 times molality, which is 0.215 times mole of ion, which is 4 ions, okay? 4. 3 plus 1 will be 4. So delta TB is equal to, we will calculate delta TB, which is 0.438, I think, yeah, 0.438 Celsius degree. But this is delta TB. We're looking for the boiling point of the solution. So if delta TB is this, at 100, boiling point of the solution will be 100.438 Celsius degree. So this is about this question, which is very important. So please make sure to solve this question again. I know that I solved it very, very fastly, but we don't have enough time. What can I do? Okay, this is the best thing that I can do for you, my dears. Osmotic pressure, yalla, let me give you some general informations about the osmotic pressure. Yalla. I will only explain some important things about the osmotic pressure, not the whole things. Yalla, first step, we have a U-shaped tube, okay? There's a semi-permeable membrane, okay? U-shaped tube. There's a semi-permeable membrane. Why we call this semi-permeable? Because it allows to pass some particles through it while blocking some of the others. Which particle can pass? Water or solvent? Yeah, can pass through this membrane, but solute, such as sugar, cannot, okay? It's prohibited to go through here, okay? Yalla. So then we will use 2 equal amounts, not 2 equal concentrations, okay? We will use 2 equal amounts of solutions, but with different concentration. Their amounts must be different, but their concentrations, their amounts must be equal, but their concentrations must be different. This is the point, okay? So, example, here we have sugar in water, okay, sucrose solution, and here pure water. It's okay if we use sucrose solution at both sides, but their concentration must be different, as I said, okay? So what will happen? Anytime when we separate two different concentration solutions, look, this is very important. Anytime if we separate two different concentration solutions by what? By semi-permeable membrane, what will happen? There will be a process which is called osmosis. Osmosis. So what's osmosis? What's osmosis? Osmosis, it means traveling of water particles from less cons to high cons, or from high solvent particles to less solvent particles. Look, less cons, it means high solvent particle. High cons, it means less solvent particles, okay? Don't confuse. Then water particles, they travel through semi-permeable membrane from less cons, high solvent particle, to high cons, less solvent particles. So what will happen? The level of this side will be increased, okay? And the level of this side will be decreased. So the high concentration side's level will be increased. But you know, there will be a pressure which is called pressure of solution tube. Pressure of solution. When pressure of the solution is equal to the osmotic pressure, so the level stops from rising, and at this point, the amount of water traveling for this side will be equal to the amount of water in the reverse side, in the reverse way. Okay? This is called osmotic pressure. So what's osmosis? Traveling of water particles. Okay? What are the conditions of osmosis? The concentrations must be different, and there must be semi-permeable membrane. Why we call semi-permeable membrane? Because solvent can pass while solute, no, is blocked. Good. Now chapter 2. Yalla. Chapter 2. In chapter 2 we will study some important things about the acids and bases without mathematical problems. Such an important thing, which is definitions of the acids and bases. As you know, there are three theories for the acids and the bases: Arrhenius, Browne-Sedlowry, and Lewis. Okay, yalla, let's talk about their principle of working. Arrhenius theory deals with the aqueous solution. If there is OH, it will be a base. If there's H3O, it will be acid. For Browne-Sedlowry, we're going to deal with the proton, okay? Proton donor, it's acid. Proton acceptor will be a base. For the Lewis, we're going to deal with the pair of electrons, okay? A pair acceptor and a pair donor. For the pair donor, it's a base, and the one that accepts a pair of electrons, okay, will be acid. Mister, but you know, I'm confused. Here, the donator is acid, but here the donator is base. Okay. Donator for the proton, but here it's donator for the proton, but here the donator is for the electron. They are different, okay? They are working according to something totally different. So don't confuse. Here we have some important questions about the chapter 2. I have seen these questions many times in Zhyar, mainly this one, okay? Mainly this one. Yeah, this is very important. When ammonia formed covalent bond, it behaves like, look. Which theory deals with the covalent bond immediately? Lewis. Covalent bond, it means Lewis, okay? And what's ammonia? Ammonia, it's base. So it becomes a Lewis base. Where's Lewis base? Here, okay? Yalla. Which of the following is a Lewis acid instead of Browne-Sedlowry acid? It means we want something to be Lewis acid but not Browne-Sedlowry acid. How to become Browne-Sedlowry acid? There must be a proton to donate. But look, we don't want any proton to donate because we don't want Browne-Sedlowry acid. That's why forget about this. because there's a proton and it can donate, it can behave like Bronsted-Lowry acid. So we don't want this. And these are bases. They are not acid. So look, compound containing boron, they behave like Lewis acid. It's very easy. Yalla, this one. And this reaction, what is water? Look, how to decide what is water? In order to decide what's water, we need the particle that reacts with it. Yalla, what is this? First of all, according to Arrhenius, water is just a solvent. It's nothing. Is there anything in terms of Arrhenius? No. Otherwise, we will neglect. And then, according to Bronsted-Lowry, water stays the same here. So there's no proton transfer. Forget about these answers. And according to Lewis, what is water? According to Lewis, water, either it's a base or it's nothing. Okay? So we are looking for the particle beside of it. It's acid. Okay, it's base, Lewis base, simply. But what if it's base? Water will be nothing according to Lewis also, because it's impossible to have water as a Lewis acid. Okay? In this reaction, yalla, this is very, very important. In this reaction, what is water again? Yalla. According to Arrhenius, water is nothing. It's just a solvent, so forget about B. And according to Arrhenius, look, according to Bronsted-Lowry, water is converted into H3O, accepted a proton, receives a proton, so it becomes a Bronsted-Lowry base. It's correct. And it reacts with a base. So it will be Lewis acid also? No, it's impossible. Okay? And it's not Lewis base, because the reaction between two bases again will be impossible. So the correct answer, it's only A. Bronsted-Lowry, water receives a proton. Okay, my dear, I will change this reaction. I think there's some mistake in this reaction. So it must be OH. That's why. So I will change this question. Sorry, this question is wrong, okay? I'll go to another question. But, understand the idea. Water plus base, it's nothing. But water plus acid, it's Lewis base. Okay? Yalla. Hydrogen bicarbonate. What is hydrogen bicarbonate? Hydrogen bicarbonate, look, it can donate a proton to become CO3 negative 2. And it can accept a proton at the same time to become H2CO3. So this is mean it's amphoteric. Okay? Hydrogen bicarbonate is amphoteric. Simply, which of the following is the strongest acid? So another point, how to answer this question. What is the difference between these answers? Only number of the oxygen. So there's a consequence. Let's write with me, okay? Increasing number of oxygen. If oxygen number increase, okay, what will happen? The polarity of OH bond is increased too, okay, and then the bond will be weaker and then easier to break. It will produce more H3O. It will be stronger acid. Okay, it will be stronger acid. So which one is the strongest acid? It means maximum oxygen number. Answer B. Okay, it's very easy again. Yalla. This reaction. I selected these questions because solving these questions, it's same as we review whole chapter 2. Okay, yalla. HF plus H2O to form H3O plus F negative. Look, HF plus H3O to form, where's H3O? It's H2O. Okay, HF plus H2O to form H3O plus F negative. Okay, yalla. First, identify the pairs. The first pair is yalla, HF and F. It's acid, it's base, the one that has one proton more than the other, it will be the acid one, and the one with less proton will be the base one. Yalla. H2O and H3O, which one has more proton? This one. So it's acid. This is base. The base one is this. Yalla. Tamashaka. This is weak. So water will be weak also. And these are strong. These are strong. Okay? Yalla. H3O and HF are acids, are proton donors. Yeah, it's correct. This is conjugate pair reaction. It's correct also. H2O is a weak base. Yep. Cannot compete successfully with F, which is strong base in accepting proton. It's correct. So the right answer, all of them. Okay, simply. And about the the neutralization reaction. Neutralization also, you have to know the neutralization reaction. It's important. Okay. Yalla. Write the formula equation and the overall ionic equation, the net ionic equation for the neutralization reaction between those acid and bases that they produce, that they form this salt. Look, there's no acid and base. The question gave us directly the salt, okay? So first, that means we have to return back the acid and the base, that acid and that base that they reacted to form this salt. Yeah, Ba, it came from Ba OH by 2 plus SO4, it came from H2SO4. Okay? Let's complete the reaction. The salt is BaSO4 plus H2O. Okay? This is called neutralization reaction. Times 2, the reaction become balanced. And then write their physical states. It's aqueous. It's aqueous. This one, it's solid. This is liquid. Okay? Yalla, what are the spectator ions? Mr. First, write the overall ionic equation. Okay, yalla. Ba plus 2 hydroxide ions. Okay, because we have 2 hydroxide ions, there must be 2 hydronium ions also. Okay, to neutralize each other. Yeah, here we have 2 H's. It means we have to convert them into hydronium ions. Then plus SO4. Negative 2. They are aqueous. We know the ions are aqueous, okay? BaSO4, yalla, if we split BaSO4, BaSO4, what will happen? They stay the same. There's no way to break down this compound. The bond is very strong. It's impossible. So Ba, it will stay the same, BaSO4 plus how many water molecules, okay? Tamashaka, 2 hydronium ions multiplied by 2. Or in the neutralization reaction, always try to add numbers of hydronium and hydroxide ions to get the coefficient of water. 2 plus 2 will be 4. 2 plus 2 will be 4 H2O molecules. So what are the spectator ions? Yalla, let's see. Well, there's no spectator ions. So this is overall, and this is net ionic equation at the same time. Overall is equal to the net ionic equation, okay, because there's no spectator. About the chapter 3, okay, yalla. Chapter 3, we will study some important concepts such as titration and the concepts of pH, pOH, OH, 3O, okay? So, you know, أو بسيارنا حل دكم وكو أو مراجعي بابەتەکان پێ دەکەمەوە لە داخلی أو بسيارنا كحلي دكين. Okay? يلا. Which of the following factor can influence Kw value? First of all, what's Kw? Mr. Kw, it's called ionization constant for water. Increasing temperature. If we increase temperature, the ionization will be increased. If ionization increase of water, of course, Okay, if ionization increase, it means H3O and OH, they increase too at the same time. So Kw will be increased also. That means the only factor that can affect Kw is temperature, which is direct proportion to the Kw. Okay? The hydroxide ion concentration is equal to 1 times 10 to negative 11 molar. Okay? Molar. So this solution is acid, base, neutral, or amphoteric. First of all, you know, it's okay if we decide according to the hydroxide ion, but you may confuse. So first, try to convert into hydronium ion. Then we will decide according to the hydronium. I think it's easier, my dear, okay? Yalla. If hydronium ion is equal to 1 times 10 to negative 11, so if hydroxide ion, so hydronium ion will be H3O is equal to 1 times 10 to negative 11 over 1 times 10. Okay, let me write in a nice way. H3O is equal to 1 times 10 to negative 11 over 1 times 10 to negative 14, right? Is this like this or wrong? This is wrong. Well, I don't know how to write, but please, let's write the Kw formula, then we will decide. Okay, I agree with you, my dear. Yalla day. Look, H3O is equal, H3O times OH equals to 1 times 10 to negative 14. Why 1 times 10 to negative 14? This is value of Kw. And then we will calculate H3O. Mister, it was wrong. So this is correct. Okay? So H3O is equal to 1 times 10 to negative 14 over 1 times 10 to negative 11. So it will be 1 times 10 to power negative 3. Mister, it's acid. Okay, it's acid. Good, good, good. بۆیەوە کرد قوتابیان تکایە نەچن ڕاستەوخۆ لەبەری بکەن. فۆرمولە ئۆریجیناڵەکەی بنووسە پاشان بڕیار بدە. باشە بابی من؟ Okay. In the aqueous solution of neutral, H3O is equal to 7. No, this is wrong. It's 1 times 10 to negative 7. So this is wrong. Contains neither hydronium ion nor hydroxide. Well, mister, I know that in anywhere we have hydronium ion and hydroxide ion. It's not important. Doesn't matter that it's acidic, basic, or neutral. There must be hydronium and hydroxide ion. So this is wrong. Has an equal number of hydronium ions and hydroxide ion. Yeah, it looks like good. So it's correct. Good? Let's solve this question together. Look, in order to solve this question, I will need to use all the equation formulas in chapter 3. Okay, this is very important and very complicated at the same time. Look, 2-liter solutions of CaOH by 2 has a pH of 8. Calculate H3OOH and mass of CaOH by 2 in grams if molar mass is equal to 74 grams per mole. Okay, look here we have pH. So it's okay to convert pH into POH, then calculate OH. But mister, why OH? Why not H3O? Because this is strong base. So we will need the hydroxide ion concentration to calculate its molar concentration. Then we will calculate the CaOH by 2 concentration. Okay? And after that, it's okay to calculate mole and grams. Okay? Can be solved like this. Another question? Yalla. In a titration, how many moles of sulfuric acid, aqueous solution, is required to neutralize? Look, you know, many times most of my students, they asked me, Mr. Neutralize, it means neutral salt? No. Neutralization, it's another name of titration. Titration, it has many names. One of them is neutralization. One of them is titration. Sometimes we will say equivalization, but it's out of our book, okay? So neutralization, it means titration. Don't worry. It means neutralizing the forces, the strength of hydronium and hydroxide. It doesn't mean the neutral salt. It doesn't mean that both acids and bases are strong. Look, but mister, this is strong. Okay, even if it's weak, we will use neutralization. Okay, so don't worry. Yalla. How many moles of sulfuric acid is needed to neutralize 20 milliliters, 0.1 molar solution of sodium hydroxide? First, because there's only one volume, so we will need this formula. Mole times H equals to mole times OH, okay? Because there's only one volume. So we're looking for number of mole of the acid, mole times how many hydrogens? 2 equals to sodium hydroxide is NaOH. So the number of OH is 1 times, we don't have number of mole. Okay, no problem. There are enough information to get number of mole, okay? So mole is equal to molar times liter. So convert this number into liter. It will be 0.02 liter, and molarity is 0.1. So 0.1 times 0.02, it will be 0.002 mole. Substitute this number here, okay, times 0.002. Good? Yeah. And then simplify the form. Mole is equal to 0.001 mole of H2SO4. That's all. Chapter 4, okay? Chapter 4, we will talk about the thermochemistry. Thermochemistry, okay? Energy related to the reactions. Thermochemistry, yalla. This is a very common question in Zhyar, okay? The longest one, the simplest one. Wallah, it's nothing, okay? Yalla. You know what's CP? CP, amount of energy required to raise the temperature by 1 Kelvin or 1 Celsius degree for 1 gram of the substance at its standard condition. Yalla. Here we have CP. CP is equal to 4.80 joules gram Kelvin. Look. أو بسيار حل كردني بينالين يا كم زاد بسيارة كي بخويني وبزواني ليتي بجي. Okay, first we need to understand. Okay, if 980 kilojoules of energy are added to 6.2 liters of water. Okay, good. At 291 Kelvin. Okay, what will be the final temperature? What is the final temperature? So that means it's initial temperature. Okay, so initial temperature, it's 291 Kelvin. Good. So that means we have to calculate delta T. Delta T equals to T final minus T initial. So to get T final is equal to delta T plus T initial. Okay, so if we get delta T value, we can calculate delta T. We can calculate TF simply. Okay, look, here we have CP. Q is equal to 980 kilojoules. Good, and then this is amount of substance. Amount of substance. So it's useful to get M value, mass. But how to convert liter into M? This is challenging, okay? Stay with me, I'll show you how to do it. So M is equal to 6.2 liters. First, when we have CP, we have to arrange all the other units according to the unit of CP. Okay, look, because here we have CP, the amount of energy must be in joule, but this is in kilojoule. So multiplying by 1,000, it will be 980,000 joules. Okay, this is first one, it's good. And now, but mister, this is liter. How to convert this liter into gram? Okay, stay with me. I have a trick, okay, it's very easy. Look, 1 kilogram is equal to 1 liter and is equal to 1,000 grams and 1,000 milliliters also at the same time. How about 2 liters? So 2 liters is equal to, look, let me write again in better way, okay? In a better way. Tamashaka. Stay with me. Look. 1 liter is equal to 1 kilogram, which is equal to 1,000 grams. This is rule, okay? Don't worry. Just stay with me. How about 6.2 liters? It will be 6.2 kilograms. It will be, multiplying by 1,000 will be 6,200 grams. Simply. But this is water. If it's not water, it must be multiplied by the density. Because density of water is 1, so we will use same number. But example, if I change this into ethanol or any other liquid, so the density must be given, and then we will multiply the last answer by the density. So now gram is ready. So gram is equal to 6,200. Then substitute the rule, substitute the numbers in this formula equation. Cp is equal to Qm delta T. And now here we have Cp, Q, it's ready, M, it's ready. Then calculate delta T, substitute delta T here to get the value of delta TF easily. Yalla. Be careful, please. This is again, you will see this, okay? Yalla. In this reaction, carbon plus O2 to form CO2 plus 393 kilojoules. Which of the following is correct? Look, first of all, any reaction has its own delta H. So, in any reaction, there's delta H. Any reaction has its own delta H. So don't worry about this. This is delta H always. This is delta H. So delta H is equal to this number because it's from the product side. It's exo. It must be a negative side, so it's correct. Okay? Then, about the delta HF. Mister, is this formation reaction? Look, how to know that something is a formation reaction? First, from the reactant side, there must be elements. Yeah, there are elements. And here, there must be a compound by 1 mole. Yeah, mister, also we have it. So it's correct also. And how about delta HC? It's a combustion or not? How to know that something is a combustion reaction or not? Look, 1 mole of the substance must be combined with the oxygen to form its oxides. So yeah, here we have 1 mole plus oxygen, so it's delta Hc also. The correct answer, all of them. Another question, look, another question. In this reaction, which of the following is correct? As I said always, this will be delta H. So here we have delta H. And now, yalla, how about delta HF? Delta HF, 1 mole of the product forming from its elements, but these are not elements, mister, these are not elements. They are compounds. So this is not delta HF. How about delta HC? 1 mole of the compound or 1 mole of the substance, no matter that is compound or element, combined with the oxygen, but there's no oxygen, mister. So this is wrong also. The correct answer is A. This question, yalla. In this reaction, which of the following is true? Again, as I say, this is delta H always. So here we have delta H. Is this formation? Look, 1 mole of the compound produced from its elements. Yeah, mister, this is delta HF also. So they are correct. Is there anything like this here? Yeah, this is correct. How about delta HC? This is not a combustion. It must be combined with O2, but this is not O2. So forget about all the answers that they relate to delta HC. We don't need this. We don't need this. The correct answer is A. Okay, this is formation. About the driving forces. What are the driving forces? Simply, I will explain them. There are 4 driving forces, okay? Delta S, delta H, delta G. First, we will start by these 2 driving forces. The decision according to these 2 driving forces is uncertain, okay? Look, delta H, if it's positive, it's non-spontaneous. If it's negative, it's spontaneous, but it's uncertain. That's why we will say it's more spontaneous, or maybe it's spontaneous. Delta S, if it's positive, it's more spontaneous, or maybe it's spontaneous because it's uncertain, okay? And delta S, if it's negative, it's non-spontaneous. About delta G, the decision according to the delta G, it's certain 100%. If it's negative, it's spontaneous, 100%, surely. If it's positive, it's non-spontaneous, okay? So you have to use this picture, try to screen this, and then we will use this for solving any questions, okay? Yeah, I will solve one question only about this. Look, Tamashaka, in this reaction, okay, N2 plus H2 to form 2NH3 plus 92 kilojoules. First, delta H, it's negative, okay? And then identify delta S. Delta S, look, first go according to the physical states. They have similar physical states, same physical states, so go to the number of moles. Here we have 4 moles. Here we have 2 moles. So number of mole is decreased, so delta S is negative also. Yalla, delta H, it's negative, so that means it's spontaneous, it's forward, okay? Spontaneous according to the enthalpy, according to delta H. Spontaneous according to delta H, it's correct, but according to delta S, it's non-spontaneous, okay? So the reaction is non-spontaneous, it's nothing. Spontaneous according to both, non-spontaneous according to both, no. The correct answer is A. Okay? يلا قطابيان تكا آغاتان أو فكريبي أو فكري زور جرينجا يعني أتا إساناتي تولو وزاري inequality, but this time we will calculate entropy change. This is important, please stay with me, okay? You may see this also, it's very important. Yalla. An endothermic reaction that has value of delta H is equal to plus 8 kilojoules. Okay? Yeah. That occur, it means spontaneous. At 25 Celsius degrees, so temperature is equal to 25 plus 273 will be 298 Kelvin. Okay? Calculate the entropy change. Look, gives free energy relationship. Delta G is equal to delta H minus T delta S. Okay? Yalla. There's no delta G, but we have delta H and temperature, and there's no delta S. So there are 2 unknowns. The reaction can be solved by the inequality. And any equation related to the inequality, okay, there must be same in any question like this. There must be similar arithmetic sign for both delta S and delta H. Because it's positive, so it must be positive also. Okay, try to substitute the arithmetic signs here. It will be positive delta H plus times negative will be what? Will be negative T delta S. Okay, yalla. So at low temperature, at high temperature, okay, yalla. At low temperature, delta H is greater than T delta S. Here, T delta S is greater than delta H. Okay, yalla. Here, delta G, it's positive. It's non-spontaneous, but we don't know. We don't need this because the reaction asked for the spontaneous. Here, delta G it's spontaneous, so delta G it's negative. That means we will need this. Okay, yalla. Try to substitute the numbers. You will get the answer. Okay, so T 298 delta S greater than 8. So delta S greater than 8 divided by 298. You will get the result easily. Okay? About the chapter 5, I think we don't have enough time even to solve more questions about them because actually we have 9 chapters. But you know, I'm trying to do my best. Okay? about chapter 5. Chapter 5, energy of reactions and reaction pathway. Okay? So, you know, again, أو بسيارة حل دكام مراجعة قانون كاني هم لسر دكينه. وشبابي من تمام؟ يلا, let's see. For the energy diagram that provided below, calculate the amount of energy that required for the endothermic reaction. Look, what mean by the energy required for the reaction? Well, mister, this is definition of EA. This is explanation of EA. But which EA? EA or EA prime? Which one? Look, that's the point, okay? How do we know that? We have to calculate EA or EA prime. Look, first of all, yalla, check the energy levels for the products and the reactant. Here we have reactant, here we have products. Okay? Look, energy of reactant is greater than energy of the product. Okay, that means it's exo or endo, it's exo. So if it's exo, the forward direction, it's exo, and the reverse direction, it's endo. And we will use EA for the forward always, EA prime for the reverse one. So now, calculate the energy that required for the endothermic reaction. Endothermic comes with EA prime in this question, but not always, only this question. That's why we have to calculate EA prime. So how to calculate EA prime? You know how to calculate EA prime. It's very easy. Here we have energy of activated complex, which theory EA prime equals to energy of activated complex minus energy of the product. Okay? Yalla. Energy of activated complex is theory 30 minus negative 20. So it will be 50, easily. Look again. Calculate the amount of energy that required for the endothermic reaction. You have to know that it's EA or EA prime. First, check the energy levels. If it's exo or endo, it will be for the forward direction, and the reverse direction will be the reverse thermochemical process. Yalla, here we have some common important questions about chapter 5. What will change in activated complex? Okay, in activated complex, do you remember what will happen in activated complex? Sometimes there will be bond formation and bond breaking, both of them. Okay? Yalla, which of the following releases energy? Look, bond formation and bond breaking. For the bond formation and bond breaking it's endo, absorbs energy, and bond formation releases energy, it's exo, releases energy. Which of the following releases energy? It means exo. Yalla, which one is the exothermic process? Breaking the bond or forming the bond? Bond formation. So bond formation releases energy. يلا again لەگەڵم بە جەماعەتکە ئەو پرسیارەیە ئەوە طبعا ئەو پرسیارە زۆر بەلەستورە ئاگاداربە یعنی بەڕاستی عەفیە لە ئەو تەڵەبەی کە بتوانێت ئەو پرسیارەی حەل بکەن. Bravo for those students that they know how to solve this question. Really, it's super challenging. Stay with me. If heat for reverse reaction, what mean by heat of reaction? Delta E or delta H, no problem. If heat for reverse reaction, delta E is equal to positive or negative? Positive. That means the forward direction, delta E, will be negative. So always we will use forward or reverse to answer this kind of question. We will need the forward direction, as I said. Remember, لكاتي دوامي أنا منظور بزواني خويندي هميشه زانياري كان لبو فوروردية باشا ده. So that means, however, it's positive, but the reaction it's exothermic. Why? Because mister, this is for reverse direction, and the forward direction it's exo. For the exothermic reaction, we know that EA prime is greater than EA. simply. Another question. With increasing time passage, how does the rate change? You know, rate is equal to cons per time. Okay? So that means rate is direct proportion to the cons, and at the same time they both reverse to the time. So if time is increased, concentration will decrease and rate will be decreased too, easily. Look, with increasing time, the concentration will be decreased, the rate will be decreased. Because concentration is decreased. Okay. Another thing about rate influencing factors, always there will be a question about this rate influencing factors. There are 5 factors that they influence, that they fluctuate, or that they affect the rate of the reaction. They either increase or decrease the rate, okay, depending on their increasing and decreasing nature of reactants. You have to know what's the reason of nature of the reactants. The reaction rate depends on the particular reactants and bonds involving in the process. Concentration, increasing concentration, number of particles increased, so collision increased and rate will be increased because of increasing the effective collision. Effective collision will be increased, so the rate will be increased. Surface area, it's special for the heterogeneous reactions, mainly surface area for the solid reactant, okay? Increasing surface area, let me write this also. If surface area increased, okay, so the reaction rate will be increased because of exposing more surface area to the reaction. Okay? Temperature. If temperature is increased, what will happen? Increasing temperature, kinetic energy will be increased, so collision will be increased, effective collision will be increased, so rate will be increased. About the catalyst, the most important one, I will give you more detail about the catalyst, okay? Yalla. How does the catalyst affects the reaction rate? First, let's solve the following questions. Which of the following burns faster than the others? Okay, burns faster than the others. First, if you see the choices, they're related to the surface area. Powdering, lump, crush, chunk, you know, it means we are working with the surface area. Lump of coal compared to powdered coal. Which one? Look, faster rate of reaction, it means more surface area. Okay? More surface area. Yalla, A compared to B. Which one provides more surface area? Of course, B. So forget about A. And compare B with C. Small pieces of coal. Of course, this one provides more surface area. Okay? They all burn by the same rate. It's impossible. So the correct answer is powdered coal. The rate of burning coal in O2 related to, okay, is related to, look, tamashaka. Burning coal, first of all, coal, it means carbon plus O2 to form CO2. This is heterogeneous reaction. So this reaction can be affected by changing the surface area and the concentration, both, okay? Heterogeneous reactions, the reaction between gas and solid particle can be affected by what? By concentration and by surface area at the same time. But for the homogeneous reaction, only concentration will affect. Okay? Yalla, tamashaka. So the rate of reaction can be affected by what? Surface area and concentration, both of them. The powdered coal compared to the lump of coal. Look, they have same source of burning, which is nothing mentioned. It means they have same source of burning, but their surface area changed. Powdered related to the lump, it means their surface areas changed. That means the reaction rate, in this case, related to only surface area. Okay? Look at this question. Coal in pure O2 burns faster than in air. Look, this time we didn't change anything about the surface area, but We just changed the source of burning, which is O2, pure O2, in one case, and in another case, we have used air. So this time, it's related to the concentration, okay? But generally, they both affect the rate of the reaction. Another thing about the catalyst, which is very important. For me, this table, it's very nice, okay? Stay with me, A catalyst. When we use catalyst can change something like this. Look, catalyst, first of all, it increases reaction rate without being consumed. I'm talking about itself. It will stay the same. It will increase the rate without being permanently consumed. This is catalyst, okay? But how? Look, using catalyst, energy pathway change it and is decreased, okay? Energy of the activated complex change it, it will decrease also. Energy of activation energy, I mean activation energy for forward, it's EA, it will change and it will decrease, okay? Activation energy for reverse, it will also change and decrease, but look, they both change by the same quantity, amount, okay? By the same number, they change, okay? Number of active collisions will be increased, okay? Look, this is very important. Energy of reactant, energy of product, and energy of reaction will stay the same. That means using catalyst, EA prime, EAC, energy of activated complex, they change it and they decreased, okay? These two by the same amount. Oh, they all change by the same amount actually, okay? And energy of reactant, energy of product, they stay the same, they don't change. That's why energy of reaction will stay the same. So a catalyst cannot affect energy of reaction. Why? Because it doesn't change energy of reactant and energy of product. Or it will change activation energy for both forward and reverse by the same amount. That's why we get point number 8, okay? Rate of reaction, of course, it will be increased and time will be decreased. Increasing rate decreases time. I love to solve this question. Wallah, I love to solve this question. Okay? Stay with me. For this reaction, NO2 plus CO to form CO2 plus NO. Okay? Suggest a reaction mechanism. Suggest a mechanism for this reaction. First, what are the requirements for the reaction mechanism? First, the overall reaction, we have overall reaction, and rate law, we have it, and intermediate species, which is NO3. Let's write the steps. Slow step. How to write the slow step? We will start by the rate law, okay? The powers will be the coefficients for the slow step. Two nitrogen dioxides, okay, 2NO2, and finish. Okay, so slow step we will need rate law, as you know, and then write the intermediate species, which is NO3. It's NO3. Okay, then write the residue of the balance. How to write this part? Compare this part to this part. Okay, here we have 2 nitrogens. Here we have 1 nitrogen, so we will need 1 nitrogen. Okay, 4 oxygens, 3 oxygens, we will need 1 oxygen here also to become balanced. So we will write NO. Okay, then write the fast step. Fast step. How to write the fast step for such a question? Look, fast step, it's very easy. When we have 2 reactions, just subtract them, you will get the other reaction. Okay, it means if we have fast and if we have slow and overall, just overall minus slow will be fast. If we have overall and fast, overall minus fast will be slow. Okay, just subtract the coefficients of overall to the slow step. Here we have 1. 1 NO2 minus 2 NO2, 1 minus 2 will be negative. Negative NO2. So because it's negative, we will write from this side to become positive. Okay? 1 minus 2 will be negative 1. We will write from this side. Okay, then, yalla. 1 CO minus, here, is there any CO? No. 1 CO minus 0 will be CO. But mister, what do we have to do with the intermediate? The intermediate must be written from the reactant for the first step. So intermediate must be written here. Okay? Yalla. Again, I will repeat this step, please. It's very important. Yalla. First step, first write the intermediate, which is NO3 plus. Just تنها coefficientەکانی overall minus step okay deep okay, only subtract the coefficient for the overall, okay, to the other steps. Look, 1 minus 2 will be negative 1. Because it's negative, we have to write it from the other side, NO2. Okay, then 1 CO minus 0, we will need CO. Go to the side, yalla. 1 CO2, is there any CO2? No, so write CO2 as it is. Plus 1 NO minus 1 NO will be 0. So we don't need anything else to write. But the point is, this step must be balanced and this step must be balanced also. Then if we add them together, we will get the overall directly. Okay? So that's all about this question. Chapter 6. Okay, yalla. I will give you a brief detail about chapter 6, a nature of chemical equilibrium. In this chapter, we will study, we're going to study those reactions that they occur with this direction. Okay, it's here. Yeah, it's here. So we're looking for those reactions that they occur with this direction. This is called reversible. This is called what? Reversible reaction. Okay, reversible reaction. Okay. So one of the most important thing about the reversible reaction is equilibrium constant, symbolized by K. Okay? So just try to understand this table. It's very important. Yalla. Value of K could be greater than 1 or smaller than 1, equals to 1 or nearly 1. Okay? Each value, any value of K stands for many informations, many things. Yalla. First of all, any reaction that occurs by this direction. The initial point, initially, they favor forward, always. They favor what? Forward. Okay? At the equilibrium, both forward and reverse direction, they are same. Okay? They occur by the same rate at the equilibrium. Okay? The dominant concentration, it means which one is dominant, the product or the reactant. It depends on the K. If K is greater than 1, in this case, the dominant concentration will be the product. Okay? If we have more product, it means the extent of the conversion, it means reactants are more converted into the products. So the extent is more. More reactants are converted into the products. Okay, if K is smaller than 1, again, initially the reaction favors forward or direct. Okay? You know that they are not equal, so the reverse one is favored. At equilibrium, both forward and reverse, they are equal always. So these are always correct. Okay? The dominant concentration, in this case, reactants are dominant. That means less reactant is converted into the product. So it's less. The extent is less. Okay? If K is equal to 1, again, initially, the reaction favors forward. Okay? At the equilibrium, both are equal. Okay? Forward is equal to the reverse. Okay? But before the equilibrium, look, This is before the equilibrium, okay? I will talk about this in different way, okay? The dominant concentration here, we don't need to identify dominant concentration, and the exchange cannot be identified. The point is this column. Look, if K is greater than 1, initially always favored forward. At the equilibrium, they are equal, but before the equilibrium, could be forward or reverse. If it's greater than 1, it means before the equilibrium favors forward. If it's smaller than 1, again, initially it's forward. At the equilibrium, they are equal, but before the equilibrium, the reaction favored reverse direction. And if K is equal to 1, they both equal. They occur by the same amount. Okay? تمام؟ هیوادارم توانی بێتم کەوا سوودێکتان پێ بگەینم بەداخەوە هەر ئەوەندە کاتمان لەبەردەست بوو. هیوای سەرکەوتنتان بۆ دەخوازم بۆ بەیانی هەروەکو وتم تەناوەی ڕلاکس بۆ سەری لە خۆت مەشێوێنە ئینشاءڵڵا زۆر باش دەبی و دڵنیاش بەلەوەی پرسیارەکان لە خوارەوەی توانایتوە لەسەرەوەی توانایتو نییە ئەکید هەر ئەسیلەک بێتەوە پێت حەل دەبی تەنها ئەوەندەی ڕلاکس بە پشت بەخوای ببەستە خوێندنی خۆت بە باشی بکە ئەوشۆ بە باشی بخۆ بەیانی نانەکی باش بخۆ بڕۆ ئیمتحانی ناوی خوای لێبینەوە ئینشاءڵڵا سەرکەوتوو دەبن خواتان لەگەڵ